Hey Leetcoders, today we are going to solve the first missing positive problem, which is a Leetcode hard problem. The problem statement: given an unsorted integer array, find the smallest missing positive integer. Here in the example 1, we have input array with values 1, 2, 0. Here the smallest missing positive integer is 3. In case of example 2, we have input array with values 3, 4, -1, 1, and clearly the missing positive integer here is 2. In case of example 3, we have array with values 7, 8, 9, 11, 12, and the clear smallest missing positive integer is 1 here. So from the examples, we can clearly see that the smallest missing positive integer is always lies between 1 and the array.length plus 1. Both 1 and array.length plus 1 are inclusive. So actually we can solve this problem if we can store the array input values into some kind of hash table or hash set, and later we can see the smallest missing positive integers are in that hash table or not. If those numbers are not exist in the hash table, we can say that that is the smallest missing positive integer. Time and space complexity for this approach is of n. But this question is asking about to use the constant extra space. That means we need to reduce the space complexity to O of 1 instead of O of n. To understand how can we reduce the space complexity, let's see few more examples for this problem. In this example, we have an array with values 1, 6, 3, 4, 5 and 2. The array having length 6, hence we can simply say that the smallest missing positive integer is between 1 and 7, both inclusive. To identify the smallest missing positive integer in this array, we can simply make sure the array elements are at right index. If the array elements are at right index, we can simply compare the elements at each index and we can simply return the what is the smallest missing positive integer from the array. So first of all, we need to make sure the array elements is at right index. So for that, let's iterate through the array. We'll start at the index 0, where we will look at the array element. Here at index 0, we have array element as 1. The element 1 must sit at index 0. In our case, it is sitting at index 0 only. So don't do anything. Move to next index, which is 1. So now at index 1, we have array element 6. The element 6 must sit at index 5. Here in our case, it is sitting at index 1. Hence, we need to swap the element 6 with the element at the index 5. So let's do that. Now we swap the element at index 5 with the element at index 1. Now let's move our pointer to index 2. At index 2, we have element 3. The element 3 must sit at index 2. In our case, the element 3 is sitting at index 2, hence we don't do anything. Let's move our point to next index, which is 3. At index 3, we have an element 4. Element 4's right position is index 3. In our case, the element 4 is sitting at index 3 only, hence we will move our pointer to next index, which is 4. At index 4, we have an element 5. The element 5 must sit at index 4. In our case, it is sitting at index 4 only. Hence, we won't do anything and moving our pointer to next index. At index 5, we have an element 6. The element 6 must sit at index 5. In our case, the element 6 is sitting at index 5 only. Hence, move to next pointer, which is out of the array. Hence, we can conclude that the missing positive integer is 7 here. Now take a look at the another example with an array with values 8, -2, 6, 1, 2, -1. So these are the random values. So now let's apply the same logic here as well. At index 0, we have an element 8. The element 8 must sit at the index 7, but we have an array length with 6 only. So we can't make the element 8 to sit on index 7 because we have only indexes up to 5. Hence we will ignore this and will move to next index. At index 1, we have an element -2. The element -2 must sit at -3 index, but the array index will only starts with 0. We don't have the -3 index. We will ignore this as well and move to next index. At index 2, we have an element 6. The element 6 must sit at index 5. So we need to swap the element at index 5 with the element 6. Now swap. At index 3, we have element 1. The element 1 must sit at index 0. Hence, we need to swap the element at index 0 with the element 1. Let's swap it. Now move to next index. Here at index 4, we have element 2. The element 2 must sit at index 1. So we need to swap the element at index 1 with the element 2. Let's swap it. Now move to next index. At the index 5, we have element 6. The element 6 must sit at the index 5. In our case, which is sitting at right place. Hence, we need to move to next index. With this, we made sure that the array elements are sitting at the right positions. Now we can simply compare the elements at each index and we can tell what is the smallest missing positive integer. So here in this case, our missing positive integer is 3. Now let's code this logic. With the examples we identified, we have to do the 4 steps to solve this problem. First step is to identify the array element which is not at right index, and the second step is to swap that element with the right index, and third step is to repeat that process until we place all the elements of the array to right positions, right indexes. Fourth step is we need to identify the smallest missing integer by comparing with the indexes of array after placing all the elements of the array to right positions or right indexes. So let's do it. First of all, we need to take the int index which is pointing to 0. Our index is pointing to 0 and index is less than nums.length, array.length. Now we need to identify the array element which is not at right index. For that, first of all, let me check our nums of index array element is greater than 0. This is because we need to ignore the negative elements of the array. We don't do anything if we get the negative elements. And also we need to check our nums of index is less than or equal to nums.length. This is because we need to ignore the array values which are greater than the array length. In that case also we won't do anything, we'll simply ignore. Now array element is greater than 0, it's not a negative number and it's not exceeding the array length value. Now we need to check the array element is at right index or not. Nums of index -1 is not equal to nums of index. Then we have to swap nums index with nums of index -1. Otherwise we just need to increment the index. With this, we have done up to step number 3. Now we need to perform the step number 4. So for that, let me take a loop for int I equal to 0, I less than nums dot length I plus plus. If nums of I is not equal to I plus 1, that means we just return the I plus 1. Otherwise, we will return nums dot length plus 1. Now let me write this swap function. Private void swap, which will take integer nums int I, int j, int temp equal to nums of I equal to nums of j, nums of j equal to temp. That's it. Let me submit my code. That's it about the first missing positive problem, which is a Leetcode hard problem. Thank you very much for watching. Please like and subscribe for more videos.